Sign numbers. Then sign and unsign. Sign, unsign. Sign, unsign. There are plus minus. Anith එක floating points versus integers. Now, if I took integer, the size is 22 bytes. Now you can imagine what is the size of the byte. Byte size. Size එක බලන්න. එතකොට you know the 32 bytes. 32 bytes size එක integer. Then you can go somewhere around 65,000 to minus 65,000 like that. But no floating points. Then if I use integer age 20, maybe there is a mob. බලන්න 65000ක් විතර යන මේක ලොකු box එකක්. ඔයාලට ඒකයි මම අර කලින් think about the cage. මේ cage එක ලොකු cage එකක්. මේ පැත්තට 65000ක් පුළුවන් මේ පැත්තට 65000. මම දාන්නේ චූටි item එකක්. ඒ කියන්නේ 20 කියලා දාන්න. see space එක waste වෙනවා. එතකොට මොකද වෙන්නේ? මේ space is සමානයි මොකේද? memory. Your computer memory. Please know that your computer memory is something like a snapshot of your computer memories like this, and there is a resident part. Resident in the sense operating system already took the portion of this memory, and the other applications took portions from the memory, and memory එකනේ හැමදේම load දෙන්නේ. ඊළඟට මේක තමයි free space. So if you are creating a data type whatever in the memory, so it will allocate the space. ඒ space එකට තමයි අපි value එක මෙතනට දාන්නේ. මෙතන මේ value එක දාන්න drop කරන්න. First we allocate a space to store the variables. මේ story එක හරියටම ඔලුවට දාගන්න. එහෙම නැත්නම් ගොඩක් ළමයින්ට තේරෙන්නේ නැහැ මේක concept එක. මේකයි පොඩ්ඩක් සිංහලෙන් උත් කියලා දෙන්නේ. And තව එකක්. Let's say I want me to add let's say double, let's say value 2 is equal to 3.1441 like that. This is a kind of a fractions. එතකොට මේක floating points දශමත් එක්ක. එතකොට මේ දශම දාන්නදී මේ දශම මේකට හරියන්නේ නැහැ. See, these are integer numbers. එතකොට we have to use a floating or double. Double කියලා කියන්නේ 64 bytes. ඒ වගේ ඉන්නේ. එතකොට මේ so the story like that. Then you need a big box, a very big box. ඔයාලා ඒක පොඩ්ඩක් කල්පනා කරන්න ඕනේ when you are working with the especially let's say when you are working with the data types, what is the suitable data type? This is very important. Suitable data type. Finding a suitable data type is a big challenge because let's say there is a byte, short bytes, short integers, double values equal to the real. ඔයගේ තියෙනවා. මේකේ කටි බලන්න ඕන. This one is the smallest. මේක තමයි smallest එක. එතනින් එහාට ඔයාලට යන්න පුළුවන්. Actually right now this should be 18, this should be 32 ඔය විදිහට යනවා. It's all about talking to the memory. memory එකට තමයි අපි මේ කතා කරන්නේ. මොකද computer memory is very important thing. මම අද activity එකක් ඔයාලට දෙනවා. තව පොඩ්ඩකින් ඒක කට්ටියට group activity එකක් විදිහට කරන්න ඕන මට. ඊට පස්සේ then you have to present what are the things you find on that one. So not now, we will do it later. So here the thing is, you have the data types, and what is the size in the sense, what is the size of the memory we allocate to store this value. That is very important thing. Doesn't matter if it is a text, if it is a number, but this memory, the allocation is very important. Okay, keep it in mind. Today, we will identify different number systems, convert decimal to binary, and the octal and the hexadecimal. Let's do some calculations. Before that one, can you tell me valid or invalid number? Just tell me, is this number is a valid or invalid? Yeah. Oh, lamai. Are you asleep? Is it a invalid or valid? Can't.
Invalid, sir.
Invalid. Why you say like that? එහෙම කියන්නවා.
It's not to decimal, binary, and octal and hexadecimal is not.
Yeah, this is a invalid, but your justification is wrong. Your answer is correct. Your justification is wrong. The way you understanding is completely wrong. Any other students?
තුනේ පාදෙන් තියෙන හින්දා තුනේ පාදෙන් තියෙන 0.1 2 විතරක් මේ අතුලත් වෙන්න ඕනේ 4 5
Any other justifications? තව කාට හරි දෙනවා justification එක? කතා කරන්න ළමයි. මේක මොකද evening session එකක් නේ මේක. So let's discuss then after.
Numbers 3ක් එන්න ඕනේ sir.
Now, you should know. So I ask, let's say, yeah, is it a valid? Now see, this is the base. So the base is 3. If the base is 3, you can have 0, 1, and 2. That's all you can have. ඉතින් එහාට තියෙන්න බෑ. මොකද ඕනම බේස් එකක් තියෙන්න පුළුවන්. හැබැයි මේ බේස් එකේ මේ මොකද්ද මේ මෙතනින් බේස් එක රෙඩික්ස් එක චෙක් කරලා බලන්න. Then can I have 4? Can I have 3? Can I have 6? No. Base is 3. Therefore, this is a invalid. Make a kattita therunana. I think you know the principles of number systems. එකයි මම කියන්නේ පොඩ්ඩක් කල්පනා කරන්න එකපාරටම don't make expert judgment. හරි. අපි තව එකක් බලමු. Like that. All right. Now, can you write down this one? A B C D. Write down in positional number system or represent in weighted score. ඔය කට්ටියට මම කියලා තියෙනවා පොතක් තියාගන්න. ඒ පොතේ try කරලා බලන්න weighted score model එකට ලියන්න බලන්න. හැම වෙලෙම පොතක් තියාගන්න මොකක් හරි. කොළ කෑල්ලි වලට වැඩිය. So you can have one exercise book. Then you can rewrite. Or when I assign something, you can try. Okay, now let's try this one. So you can have this should be, we can start from right to left නේ පටන් ගන්න. එතකොට මේකේ මොකද්ද weight එක දාගෙන යන්න මේ විදිහට. මතකයිනේ? practice කරලා එන්න ඕන. මට පේන ළමයින්ට පොඩ්ඩක් මේ follow up කරනවා මදිද මන්ද. All right, then you can have a is equal to 10. A B C D E F. Now these are the characters used in hexadecimal. This is represent 10, 11, 12, 13 and the 14, 15. See, every time if it is 16 less than 1, should be minus 1. There are 15 in it. Here then you can say A is 10 into 16 to power 1 plus A, or you can say 10 into 16 to the power 0. Then B is 11, 16 to power this should be 2, no? This should be 1, this should be 0, plus C is equal to 12. Then, but here, please mention this should be a minus 1, 16 to minus 1, plus D is 13, 16 to minus 2. This is the evaluation of positional number system. හරියට කරන්න. If not, you will be in trouble. Because these things are basics. If you don't know these things, very difficult to understand the color mechanisms. Because the color code in computer recognized by the hexadecimal. The last time we discussed your computer, they can't understand what we are talking. So there is a conversion every time, analog to digital conversions. So we press button, then it generates a bit stream. According to the bit stream, the CPU and the memory will generate the pulses or clock speed. Then there is a cycles ongoing. That cycle is called as a fetch and execute life cycle, and do the process. ALU, control unit, and other registers will elaborate to do these things, and finally we have the output. Okay, මේ විදිහට තමයි යන්නේ. හොඳට ඔළුවට ගන්න මේක. And don't write when you are writing down something. Let's say don't use for the hexadecimal A, B. This is wrong. Huh? There is no lower cases. You can have A, B like that. Even the capital F like upper cases. Okay. Now, let's move to number system. Identify the number systems and convert decimal to binary and decimal to octal, decimal to hexadecimal. Right. Now, these are the popular number systems. You can encode it to the any numbers, any bases. But the problem is, there is a famous number systems we use day-to-day operation. 10 day-to-day lives. This is our natural base. That's why we are not mention the base here or the radix here. But the computer, this is a computer term. The computer will understand only the binary. That is a two condition, yes, no, true, false, or we called as it is a ones and zeros. See, better to mention the radix and the octal. You have 0 to 7 digits, and here mention the 8 octal. It's rare condition. It's a rare number system. But the hexadecimals, we can see if you open the color palette in the computers here, there you can see the hex. For example, that the black keys represented by the RGB, red, green, blue. Then red is say 0 to 25 like that. Therefore, it is maximum go for FF. So all together, this is red 25, green 1 to 255, and the blue to 255. Then all together black. This is the way how to represent the color in the computer. Anyway, sometimes in the number systems, the hexadecimal will write as hex and the radix as 16. But keep it in your mind when you are writing down. Let's say if this is the number, here we put the base, here we put the power. So we called as this is a subscript, and here the superscript. So write down in small letters. Okay. Then the base and radix, the number of different symbols required to represent any given number. If the base is 10, you can go for this range. එකදී the ප්‍රශ්නේ මේ මොකද්ද just give me 1 minute. So many people are calling. Okay, let's come back to the lessons. Then base 2, 0, 1 එක හරිනේ ඔයාලා දන්නවනේ. Zeros and ones තියෙන්නේ. The base 8 again, you can go for the zeros and here until 7, because these things are weighted. Weight. These are the possible numbers, and the hexadecimal can go like this way. The largest valid number in the radix, it is the one less than to the radix. That is true, no? because in the 16 less than 1 less than to the basic radix, the 16 minus 1 the 15, therefore 15 is represented by the F. Even if it is the octal situation, the octal the base is 8, then 1 less than it should be the 7. See, therefore you have the highest number, the largest number, valid number is you can calculate. Take a product balanna. Okay, so these are the possible numbers. Number of symbols and number of digits. Yeah, for the given numbers, the larger base, the more symbols required. So hexadecimal has 16 symbols and binary only have 2 symbols. Therefore, according to the numbers, the complexity the 2 digits is necessary, and sometimes we have to go for 3 digits in octal, but again you have to convert into the binary. There you can go for the 8 digits. So the conversions among bases, this is okay. And now in the computer memory operated with the binary condition. So the binaries work with 2, something like that. Then 2 to the power 0, 2 to the power 1, likewise 2 to the power 10. So in the last time we discussed about the byte kilobyte conversions. Then 1024 bytes equal to the 1 kilobyte. Kilo. Okay, kilo 2 to the power 10. 10 times වැඩි කරගෙන යන්න ඕනේ. මේවා මොකද මම මේවා පොඩ්ඩක් මුලින් ඉඳන්ම කියලා දෙන්නේ. Some students they are okay, and some students they are very new to this. Someone's come from art stream මගේ එතකොට මම ඒ දේවල් කියලා දෙන්න ඕනේ. හරි. එතකොට මුලින් ඉඳන්ම යන්නේ. So 1 KB here you can see 1 KB can encode like this way, expand කරලා ලියන්න පුළුවන්. If someone is asking why the 1024, the reason is මෙන්න මේක, because of 2 to the power 10 times වැඩි වෙන්න ඕන. හරි. memory buffer memory එකට අපි තව වචනයක් කියනවා in the computer buffers. All right, in the computer memory is operated with the normally work with the binary, that is the base is 2. Fine, but this is the way how we are going to use me api inne. So we work with the base 10 only වැඩ කරන්නේ. So 10 එක convert වෙනවා immediately, that is normally analog to digital conversion එක. Whatever our voice එකක් හරි, our image or whatever things, it should be converted into binary format. If the binary is stream, then from the binary you can encode it to the other bases like octal. If you have the binary, you can convert into the octal, that is the base is 8. Okay, then if you have the binary, then you can again convert into the base is 60 hexadecimal. Fine. And not only that, again the octal is directly converted into decimal, and also the vice versa. Once you have the octal, you can again turn back to the binary. So computer do these things, conversions, under the arithmetic logic unit. Arithmetic part is controlled by this ALE. මේ conversions මේ විදිහට වෙනවා. එතකොට අපි දැනගන්න ඕනේ මේ conversions කොහොමද වෙන්නේ කියන එක. ඒකට main thing is, first you should know how to convert a decimal to the binary. එකෙන් අපි ඉස්සෙල්ලාම කතා කරන්නේ decimal to binary, ඊළඟට binary to decimal, how to do it. Right. So First, we will see decimal to binary. To conversion decimal numbers into the binary, the technique is we can take the base out 2, and then after take the number and divide. Here you can divide and you can put the value, and here you can put the remainder. The remainder එක දාගන්න. ඒ විදිහට you can do some serious calculations. Finally, you have to be complete until you have the zero. එහෙම නැත්නම් end එක මෙතනින් එහාට බෙදන්න බැරි වෙනකම්ම බෙදාගෙන යන්න ඕන. Alright. ඊට පස්සේ මොකද කරන්නේ? Then we are going to read the content from bottom to top. Bottom එකේ ඉඳන් top එකට content එක read කරන්නත් ඕන. Right? දැන් අපි පළවෙනි conversion එක කරලා බලමු. Within 125. See, 125 is divided by 2. Then you have 62. Then you have, this is the remainder. In the remainder, then again 64, 2 is divided by 2. You have 31. හරියට බෙදන්න ඕන. No remainder. And then again 31 is divided by 2. The repetitions. මේකට කියනවා අපි එකම දේ again නැවත නැවත continue කරනවා. එතකොට here you have the 15. Then you have the remain. Remain එක කියලා කියන්නේ දැන් මෙහෙමනේ එන්නේ. එක මේ දෙකෙන් බෙදුනොත් එහෙම මේකට 20 30. එතකොට 31කින් අඩු කරපුවා remain එක එකක් එන්නේ. කොහොමද? ඒක තමයි මේ තියෙන remains ටික දාගෙන යන්නේ. Then 7 is divided by 2. Then you have 3. මේ තියෙන remain. 2 to the 2 into 3 is 6. සමහර ඒවා බෙදෙන්නේ නැහැ. මොකද තියෙනවනේ even numbers තියෙන odd numbers තියෙනවා. Even number එකක් ආවම definitely we can divide by 2. But if it is odd number, so definitely there is a 1 remain. Then here continue, and then finally 3 is again divided by 2, and you have actually exactly the 1, and the remainder is 1. ඔය විදිහට තියෙනවා. ඊට පස්සේ මෙතනින් එහාට බෙදන්න බැහැනේ. එතකොට අපි මොකද කරන්නේ? මෙතනින් ඉඳන් මේ ටික රීඩ් කරගෙන යන්න. Bottom to top. So how to write down? 1 1 1 1. හරියට රීඩ් කරන්න මෙතන ඉඳන් 1 1 1 1 and 101. There are 2 කියලා දෙන්න. So this is the conversion. මේ තමයි conversion. So this is the technique. හැබැයි ඉතින් මොකක්ද here you have to be very careful, because when you are dividing the number is there is a calculation mistakes තමයි ගොඩක් වෙලාවට තියෙන ළමයින්ට. Because of your hurrying, you have a 2-hour paper, and so you are not comfortable. So practice. ඉක්මනට පුළුවන් වෙන්න ඕන. You should have developed your division skills with the 2. If not, you can't get the best stream of this decimal number. So ඒක වැරදුනොත් එහෙම ඔක්කොම වැරදිනවා. මුලින්ම ගන්න ආන්සර් එක අනුව තමයි අනිත් question ඔක්කොම අහන්නේ. Because first they are telling the decimal number, then they will ask convert into binary, and then convert into the octal, convert into the hexadecimal. So if your first response is wrong, definitely so everything will be wrong. එහෙමයි වෙන්නේ. ඒක හරියන්නේ නැහැ. Like that. Within මෙතන ඉඳන් read කරන්න. මෙතන ඉඳන් bottom එකේ ඉඳන් top එකට මෙහෙම read කරන්න. ඊට පස්සේ මෙහෙම ලියාගෙන යන්න මේ පැත්ත. Right. I think bottom to top අපි පොඩි exercises ටිකක් කරමු නේද? එකම දේ තියෙන්නේ ඉතින් 6 bits. All right. So first Iselam. These are the question for you. 1, 2, 3. තුනක් දෙනවා මම. So you have to try. You need to, everyone has to do these things with these classes just in time. Now, first one is right. Do it. කරගෙන යන්න බලන්න.